Hello, today we are going to know what is fixed point of a dynamical system. Now, what is dynamical system? Dynamical system is the system that change with time. System which changes with time known as dynamical system. Let's consider a motion of a object in a rectilinear path. In this path, what happens? In this path, the position of the system or a body changes. So I can say this is a dynamical system. And this dynamical system is defined by the coordinate. And what is the coordinate? The coordinate is x. Okay. Then now what is fixed point? Fixed point is the point for which the dynamical system does not change, or fixed point is the condition at which the dynamical system does not change, or I can say with evolve of time, with change of time, the point does not change. That is, if x is the coordinate, if I got a point such that dx by dt is equal to 0, that is x does not change with time, then this point is known as fixed point. If I solve this and I get x is equal to x0, then I can say x0 is fixed point. I think you understand what is fixed point. Fixed point is the point for which the dynamical system does not change. That is, if the dynamical system is defined by coordinate x, then fixed point can be calculated using the condition dou x by dou t is equal to 0, because x does not change with time. Now, see in phase space. What is phase space? The combined position and momentum space is known as phase space. Okay, and this is the phase space. Here, one is position coordinate, another is momentum coordinate. Then, what is the fixed point in positions in phase space? In phase space, the fixed point can be defined by a formula dq by dt is equal to 0 and dp by dt is equal to 0. That is the point where both position and momentum does not change with time. Then the point is known as fixed point. Here, if I solve this, I got q is equal to q naught and p is equal to p naught. Then I can say p naught and q naught is the fixed point. I hope understand what is fixed point. Fixed point actually the point at which the dynamical system does not change with time. Okay, what are the types of fixed point? Basically, there are two types of fixed point. One is stable fixed point, another is unstable fixed point. Now let's see what is stable fixed point. Stable fixed point is the point if I just change the point, or I can say mm, if I just go to the nearby point, then the trajectory it is such that it move again to the fixed point. Then this is stable fixed point. Let's see the diagram. This is the stable fixed point. If I move this nearby point, then the body automatically move to this point. Hence, this point is known as stable fixed point. The stable fixed point is also known as attractor, because when the body in the nearby point, these are automatically going to become to this fixed point. Hence, this is stable fixed point. Now, unstable fixed point. Fixed point. What is unstable fixed point? If I go to some nearby point, the body does not tend to come the fixed point. Let's see the diagram. Here, this is the fixed point. If I just come to this nearby point, the body cannot come to this fixed point. Hence, this is unstable fixed point. Here, there is no chance of getting come back to this fixed point. So, this is unstable fixed point. And this point is also known as repel. That is, I can say when we go to nearby point, this fixed point repel this nearby point so that the body cannot come to the fixed point. Now, see, this is the coordinate x and this is the time evolution of coordinate dx by dt. If the motion of body defined by this curve, the attractor point can be defined by this. Just see the arrow. What the arrow says, if I just go to the nearby point, this nearby point automatically leads to this fixed point. Hence, this is attractor or stable fixed point. Now, see this point and the arrow. Here, the arrow goes away from this fixed point. Hence, this fixed point is known as repolar or unstable fixed point. Now, let's see with an example. What is this fixed point? Let we have a system which is defined by the relation dx by dt is equal to x square minus 9. Okay. Then, what is the fixed point for a system which is defined by equation? We know how to calculate fixed point. To calculate fixed point, just we have to find dou x by dou t is equal to 0 and then solve it. Then what is the value of dou x by dou t? X square minus 9 is equal to 0. Then what is the value of x? X is equal to plus or minus 3. Here there are two fixed points. One is plus 3 and other is minus 3. Out of plus 3 and minus 3, one may be stable fixed point or one may be unstable fixed point. Let's see how to find a stable fixed point and unstable fixed point. Now see, let the function for a dynamical system is given by dou x by dou t is equal to f of x. Okay. Let x0 is equal to fixed point. Okay. If I just go to the nearby point or change the value of fixed point, then what will be? The new value of x will be x naught plus epsilon. Epsilon is the small value. Now, what is the equation of the system? The equation of system is going to be dou by dou t x naught plus e, which is equal to f of x naught plus e. Now, just differentiate. What is x naught? X naught is the fixed one, so its time derivative will be 0. Hence, this will be dou e by dou t. Now, just find its Taylor expansion. The Taylor expansion will be f of x0 plus epsilon into f derivative x0. What is f of x0? Now, what is the value of f of x0? We know x0 is a stable fixed point. For f of x0 is equal to dou by dou t x0. Then what is its value? Its value is equal to 0. Hence, dou e by dou t is equal to epsilon f derivative x0. Then what will be it? I can write it by this way. Just simple mathematics. And now just see, by integrating this, I will get ln epsilon is equal to f derivative x naught t plus some constant term. The constant term will be ln c. And what is epsilon? Epsilon is equal to c into e to the power f derivative x naught t. Now let's see, if the value of f derivative x naught greater than 0, that is, if this is greater than 0, hence the epsilon value just increases. If epsilon value just increases, the body does not going to come back to its original position because epsilon increases. Hence, this is the condition for unstable fixed point. That is, here x naught will be the unstable fixed point. Because when this condition satisfies, the body is not going to acquire its original position as epsilon increases. Now let's see, if f derivative f0 decreases or less than 0. If f derivative x naught less than 0, then what? Epsilon, the value of epsilon will be decreases. As this part is equal to negative, this part is negative. As this part is negative, and just epsilon decreases. So what I can say, the when value of epsilon decreases, x tends to x naught. That is the condition for stable fixed point. So remember, to calculate unstable fixed point, what we are going to do? We are going to check whether this condition satisfy or not. For calculate stable fixed point, what we are going to do? We are going to check this condition satisfy or not. Now let's see the previous example. The previous example, we got two fixed point. One is plus 3 and another is minus 3. Are which one of these is stable and which one of these is unstable? To find it, what I should do? I should find f derivative x. What is the value of f derivative x? Here, f of x is equal to x square minus 9. And what is f derivative x? If f of x is equal to x square minus 9, f derivative x is equal to 2x. Now, what is f derivative plus 3? The f derivative plus 3 is equal to 6. And what is f derivative minus 3? F derivative minus 3 is equal to minus 6. And we know when f derivative x greater than 0, we can say this is unstable fixed point. And when f derivative x not greater than 0, when x is equal to 3, I can say f derivative x naught greater than 0. Hence, 3 is unstable fixed point. When f derivative x naught less than 0, then I can say this is stable fixed point. So, for x is equal to -3, f derivative -3 is equal to -6. So, I can say this is stable fixed point. So, for a system which is defined by this equation, I can say there is two fixed point, one is +3 and -3, and the +3 become unstable fixed point and the -3 become stable fixed point. Now, what is the fixed point for a system which is defined by an iteration equation or logistic equation? First of all, what is iteration equation? Iteration equation is the type of equation in which the next value can be find out from a given value. That is, if the given value is xn, the next value will be xn plus 1. Then, in this case, what is the fixed point? Fixed point is the point for which the next value is the same as given value. Let I say x0 is the fixed point. If x0 is fixed point, then what it will be? Then f of x0 is equal to x0. That is the next value same as previous value. When next value same as previous value, then I can say this is fixed point. For what? Fixed point for a dynamical system which is given by iteration equation. Now, how to find the fixed point in this case? In this case, to find the fixed point, we have to solve for x is equal to f of x. And by solving x, I get fixed point. Whether this fixed point is stable or unstable, how I am going to find it out? If the first derivative of x naught, f of x naught, more less than 1, then this is stable fixed point. If first derivative of x naught greater than 1, then this is unstable fixed point. How I get into this conclusion? Let's see. Let epsilon be the error. That is, if x n any point which is away from the fixed point by the amount epsilon n, and x n plus 1 be the any point which is away from fixed point x0 by the amount epsilon n plus n. Then what is the equation? The equation will be x naught plus epsilon naught epsilon n plus 1 is equal to f of x naught plus epsilon n. By Taylor series expansion, what I will get? I will get f of x0 plus epsilon n f derivative x naught. And this is x naught epsilon n plus 1. And what is f of x naught? I know f of x naught is equal to x naught because x naught is the fixed point. So x naught plus epsilon n f derivative x naught is equal to x naught plus epsilon n plus 1. By cancelling x naught, what I will get? Epsilon n plus 1 is equal to epsilon n f derivative x naught. And what is f derivative x naught? F derivative x naught is equal to epsilon n plus 1 epsilon n. If both are same, then it will just cancel out. What I will get? F derivative x naught is equal to 1. This is the condition for marginal stable point. That is, when x naught is purely stable, I will get epsilon n plus 1 is equal to epsilon n. So, f derivative x naught is equal to 1. And this is the condition for marginal stable point. No error. When error, what is the condition? When this value just less than 1, then I can say this is stable fixed point. When this value just greater than 1, then I can say this is unstable fixed point.